In this video here, I'm going to talk about how many solutions you can have to a linear system. So this question's already come up: will every linear system have a solution or a point of intersection? And the answer we talked about is no. There's actually, given any linear system containing two lines, there's three possibilities for the number of solutions. You could have one solution, which is the case that we usually see, right? One point of intersection. You could have no solutions, or you could have this third case, which is infinite solutions. So that one we'll have to talk a little bit about. But the one solution, that's the one we normally deal with, right? Like if you have two lines, we see that most line, or kind of standard two lines will have one point of intersection, and we've done that. We've done that using substitution. Every example I think we've done so far has had one point of intersection, one solution. You could also have no solutions, and that comes up if the two lines are parallel. So no solutions means lines are parallel. And I don't know when you learn that, but we talked about that in grade line, that parallel lines do not intersect. So two parallel lines won't have a solution to the system. Now we haven't seen that come up yet, but let's just do an example here. Let's say you've got y equals 2x minus 1 and y equals 2x plus 3. So we know these are parallel because they have the same slope. Okay, so if they have the same slope, we know they are parallel. So these lines are parallel, therefore they have these lines have the same slope, therefore they are parallel. Are parallel and have no points of intersection. Now, one thing that's sort of interesting here, or worth sort of noting here, is, let's say you didn't know that. Let's say you didn't know about slope, and parallel lines have the same slope. So you didn't recognize that these ones were going to have no solutions, and you tried to solve it. Well, if you were to graph it, you would see that they're parallel, right? Like they would go in the same direction. But let's say you didn't graph. Let's say you tried to do this by substitution. Just want to show you what happens when you try to solve a set of parallel lines using substitution. So when we do substitution here, since 1 and 2 are both have y by itself, then we can just set 1 and 2 equal to each other. So set 1 and 2 equal to each other, right? So they're the right sides. We're just going to equate them. So we're going to have 2x minus 1 equals 2x plus 3. So what would happen now is you try to group the like terms. So you have 2x on the left side, and then this 2x, you're going to subtract 2x. So you're going to subtract the 2x from both sides. And then you're going to have the 3. So the 2x on this side is going to kind of go away, and it's just on the left side now. And then we're going to add plus 1 to both sides. So we end up with 0, or you say 0x equals 4. 0x, you could just write 0. But if you look at what we have here, it says sort of 0 equals 4, or 0 times x is equal to 4, which is impossible, right? You can't multiply something by 0 and get 4. So this doesn't have, there's no solution, right? Since this is impossible, therefore there is no solution. And that's what will always happen. If you have a set of parallel lines and you try to do substitution, you always end up with a statement like this where it says 0 is equal to something else, to something that's not 0, then an impossible statement or a false statement, which means that there is no solution. So that's what happens when you try to do it by substitution. So let's go back and talk about the other case. So we talked about no solutions. One solution is the one we've done kind of a lot, so we won't go over one solution again, but infinite solutions. So what does infinite solutions mean? Infinite solutions means the lines are actually the same line. Okay? So infinite solutions happen when we say the lines are coincident. The lines are coincident. So the word is coincident. And that means like lying on top of each other. So same line. Okay, so for example, say y equals 1/2 x minus 3, and the same line, y equals 1/2 x minus 3. So these lines are the same line, right? If you were to graph it, minus 3, this is one of the lines, and then the other line is just right on top of it. So where are they intersecting? Well, they're intersecting at every point on the line. The whole line is a set of intersection. So that's what we call coincident lines, which almost seems like, why do we have to consider that case? Like, if it's the same line, it's going to be so obvious, like, why would we even talk about it? But remember that we're not always going to have lines in this form. So let's say I gave you two lines and they're not in y equals mx plus b form. It might not be as obvious. Actually, let's say one is in y equals mx plus b form. Let's say we want to solve the system. Y equals 2x minus, actually let's say 2x minus 6, and let's go 4x minus 2y minus 12 equals 0. So there's my two lines, which one's in y equals mx plus b form, and the other one's in standard form. So it's not immediately obvious, if these lines are parallel or coincident or not. So we might not be able to tell if how many solutions they're going to have just by looking at it. So we'll try substitution. So since equation 1 is already isolated for y, we can substitute 1 into 2. So that means we're going to take the equation for 2, 4x minus 2y minus 12 equals 0, and just replace wherever we see the y, we're going to write 2x minus 12. So we got 4x minus 2 minus 12 equals 0. So I'm replacing the y with 2x minus 6. Whenever you're substituting, you should be substituting with a bracket then. So now we'll just expand this negative 2, gets distributed into the bracket here. So we're going to have minus 4x plus 12 minus 12 equals 0. So again, like add like terms, so we got 4x minus 4x, which is 0x, and then 12 minus 12 is 0, so you got 0, which kind of looks similar to what we had in that last example, right, where we had our x's canceled out, we had 0x, but notice here I've got 0x equals 0. So when does 0x equal 0? Which values of x? And that's actually true for anything, right? X could be 1, that statement would be true. X can be 2, that statement would be true. X could be 3, that statement is true, right? Because 0 times anything is 0. So this is true for all values of x. right? The last was never true. This one's actually always true. So therefore, there are infinitely many solutions, because any value of x will be a solution, and there's infinitely many values of x. So therefore, there are many solutions. And that means that the lines are coincident. It means these lines were actually parallel. Or not parallel, sorry, coincident. They're the same equation. So therefore, the lines are coincident. And another way to see that is to just rearrange the second line. Right, if we had just taken this line up here and just rearrange, so isolate for y, right, so that you take 4x minus 2y minus 12 equals 0. You want to subtract the 4x from both sides. And you want to add the 12 to both sides. And I won't write it on the left side, but it canceled on the left side. And then divide everything by -2. You're going to get y equals -4 over -2 is 2x, and 12 divided by -2 is -6. So the line is actually the same line as the first one. But, that wasn't as obvious when it's in standard form. So you might not know that, and you try to do substitution. But again, if you have the coincident situation, you'll always end up with something like this, where you get a statement where all the x's give you a solution. So that's how many solutions you can have: 1, 0, or infinitely many. And sort of when you do substitution, that's what will happen. Either you'll get a 0x equals 0, which means infinitely many, or you'll get 0x equals, like this one, 0x equals a number which is not 0, which is impossible, therefore there's no solutions. Or I didn't do an example for the first case, but that's the one that we normally do, where you just get x equals a number.